Not bad. Screen recording started. Excellent. Good. It should be perfect, right? Recording, lecture notes, and we are only 10 minutes late. Good. Last lecture. Recap. We talked about legacy systems, right? We talked about that they do have values for companies, business value, but that often legacy systems are no longer, they might actually hinder our business at one point. Why? Because we cannot change them anymore. We have too much technical debt. The hardware, the software which we use to implement the legacy system do not support the latest technologies. So at one point we have to think about migrating to a new hardware, to a new infrastructure, to new software to meet the changing requirements. And so we looked at different issues of a legacy system, including the structure, architecture a little bit. Now, can we decompose? And also talking about estimating. How much will it cost? How much should we expect for the migration? And there are several approaches which are really similar to actually the development, to software development. So the COCOMO function points as possible approaches. And basically what we do here is we look at how many features, how much functionality does our original software actually implement, and then basically try to figure out if we migrate to implement now. Also, what we should conduct is a legacy assessment, helping us really to prioritize and see, helping us decide what strategy we want to use for migration. And what we should do is an assessment of the legacy application and how it fits in our current software ecosystem. So we should identify if it's a high value, low value, business value, and we should also look at the implementation itself. Is it, can we maybe reuse it? Can we maybe keep it? Can we still evolve it? And then we pick our battle. Okay, so we do an assessment. How important is the application for our business? And what is actually the hard software which we use? In what state is our hardware software, which we actually used to implement the legacy application? Okay, so we look at two dimensions, business value and the actual software and its availability. And depending on that one, we might come up now with different strategies. One could be retiring, one could be restructuring, etc. Right? And I think we talked about it. So here were basically some of the strategies. I'm going very quickly over them. Today I can actually scroll my PowerPoints. It actually goes fast, right? So we have different types of legacy modernization methods. Okay, that's fine. Okay, got the speaker. And Okay, good. Here again, some of the reasons why we should migrate. We talked about them. So, and then basically what we should do is we should do a transformation, right? At one point, once we decide that we actually want to retire, that we want to replace our legacy application, we should come up with some transformation strategy. No matter what strategy we use, it should be safe. Safe in terms of our business should not go down. Very important issue, right? Whenever you do a migration, often you have the two systems typically running in parallel, at least for a period of time. So you have your old legacy system, which is still working. And while you're migrating, you have your modernized, your new application running in parallel. And the advantage is you can actually observe, right, if your new system is actually working correctly. And you have always a backup. And at one point, you actually move more and more of your transactions, of your functionalities to the new system. And the idea is you really minimize the user impact on the user, and everything else. So for the migration strategy, we have to look at our application, type of application, size of the application, and also, do we have any tools which can help us during the migration process? And that's where we basically stopped somewhere, right? We talked about an example. So that was the migration of two banks. So merger of two banks. And key is the two applications here have actually similar characteristics. So they have a similar architectural style, they have similar functionality. And so one would assume it should be actually quite easy, right? And when we look at different scenarios, what we could do, we talked about, we could retire one of the systems completely. We could keep both systems going and just create a new interface. We could have a data transfer at the bottom so that we connect the databases, allow for data exchange, meaning, for example, transferring accounts, money between accounts, it stays really within your own organization, right? Such things. Good. So the options would be convert everything to system A, right? So convert the databases, retain the staff, enhance system A, and at one point, when system A is really upgraded, we could say, okay, let's get rid of B. Now, initially, our savings would not be that great because we run both systems in parallel. But once we actually convert everything to A, we would have no longer the maintenance of system B, right? So we actually start gaining something from a merger in terms of resource implications. Because suddenly we could probably get rid of some of the hardware, old hardware. We could get rid even of some of our operations and developers, because now we only have one system, which we are maintaining, right? Another approach would be build an interface between the databases in system A and B. So the databases can talk, communicate. So from a user perspective, you could have now, if a user has accounts in bank A and B, you could actually now create a common interface, right? And they could actually have access to both of their accounts in bank A and B, and they can do easy transfers which we couldn't do before that easily. And we get maybe just one statement showing them all the accounts. Okay. And then we can also extend the client software so that it can interact with either of the system. So here we would not touch the databases, we would not change the databases, we could just create a common interface. And then, you know, like I said, the one bank had mortgage accounts, the other one had brokerage accounts. And by creating a common interface, you just copy all systems. You basically create a wrapper around both systems, right? For the user interface, and from a user perspective, they can now access the mortgage and the brokerage account. But internally, the transfer between accounts would still not be easy because the databases would not be connected. With the last two solutions, we somehow keep really our both systems in place. So we don't have really much of a benefit in terms of reduced resource requirements because we still have A and B running. Okay. So that would be the example of the interface between A and B. Okay. So in our case, in our example, in all three options, right, it was really maybe the first one that we might move everything to A, right? Assuming that A would be the more modern implementation, has maybe the more modern programming languages, right? So you would have to determine, is your A or B, right? Your target in which you want to merge. So you will have to do an assessment and see how much is involved and which of these current systems would be easier to evolve in the long term, which has the higher quality, right? So it's not just A and B, right? You know, you have to determine. But no matter what you do, you want to minimize the impact to the user, to your data, to your daily business. So classification of legacy information system architecture, they should be decomposable, ideally. So what we want to see, which would make life easier, is if the systems are actually what decoupled. If you have subsystems, and we had it already during regression testing, impact analysis, what we want is an architecture, system architecture, where you have subsystems really decoupled from the other parts as much as possible. Because it opens up a lot of new opportunities also during software migration. Because suddenly we can only maybe migrate or modernize a certain subsystem, right? Rather than, you know, doing it bit by bit if these subsystems are decoupled. If we have semi-decomposable applications, example would be if the application itself, a business logic and the database can no longer easily replaced. So you cannot change the database as easily without affecting the application. In theory, you know, like if we have a three-tier architecture, the application logic would run on the application server. The databases would run on the database server, and the application typically access the databases through an API. However, over time, your original architecture might actually be corrupted because of ignorance surgery, right? Some programmers don't know where should the application logic be. They put some of application logic on the database side. some of the checks or whatever, and suddenly you have a coupling between a tight coupling between application and database server, and we are no longer easily to migrate or to switch. Worst part, everything is tightly coupled. Happens sometimes, mostly really if a system was in place for many, many years, right? So really the structure, the original design, the original architecture is really just corrupted. Programmers didn't know anymore what they were doing. And maybe even the original design, maybe the original architecture was not that great from the beginning. It happens, right? So people didn't apply any design patterns. They didn't follow any architectural patterns. They just did patch together when they develop the software. And then you end up with a problem, right? So migration here means you might have to, worst case, you might have to migrate your whole ecosystem, right? Because it might no longer just be one subsystem which you can change. You might have to change everything. Typical example, and that's what happens typically also with enterprise resource planning systems. Payroll, human resources, often even warehouse sales, right? We're all tightly integrated. So that's why a lot of companies not only change the payroll, they do actually the whole package, the whole business backbone, because there's so much interconnection that you cannot just isolate anymore, payroll from human resources. Good. So what are now some of these strategies what we can use? We could just ignore it, right? And say we can retire the software. Now that's really the case if it doesn't have a lot of business value, okay? We have an application which we were maintaining, but it's not really relevant anymore. And then I might be just phase it out and retire. Alternatively, we can try to replace an application with components off the shelf. Now, that could be even an enterprise resource planning system, right? An enterprise resource planning system could be considered a component of the shelf, but it's a large component, right? It's payroll, human resources, warehouse, it's everything, which is later on customized to your specific needs, but overall, it's a big ready-made framework. Cold turkey, we're going to rewrite it from scratch. But rewriting an application, always dangerous. It doesn't mean necessarily that we end up with something which is really much better, right? Depends on who is implementing it. There's no guarantee. Also, any application which is completely rewritten from scratch tends to have a lot of bugs initially, right? So having bugs, we need a lot of testing. There's a high risk if you go cold turkey, complete, like you're changing payroll, human resources, you say, we are going to implement it ourselves. Very tricky, very dangerous. Or we can try to inject some modern technology. So we have a legacy application, and we could try to inject now some modern technology into our application. And I will talk about it later on when I'm going to talk about migration to the cloud. Okay. So that would be an example. You have a legacy application, and then you could migrate at least part of it to the cloud. And we will talk about different levels of migration. So such a gradual migration could be just a re-architecting of some parts, right? You might do some restructuring. We might replace some parts with a new application. We could do a language migration. So you have a COBOL application and you might migrate it to Java. So, so you would basically do a one-to-one migration. Sometimes it's feasible. It's actually somewhat straightforward if you have tools which can convert. Right? So you have conversion tools, transformation tools, which can convert from one programming language to another one. Might not be a complete new language, but could be just a new version of a language, right? We also have schema and data migration. So here we talk about the databases and the data. You might move from a relational to a graph or to object-oriented database. So the data is somewhere still the same, right? But the representation, the schema is going to be different. So how do you get the data into the new schema, into the new database? And we could have a user interface migration. So these are different types of migration. You go from your traditional PC to a web-based interface, to a smartphone, right? Interface. So really, if you do the chicken little, we do it bit by bit, right? Different aspects. And we are basically phasing out, to some extent, our old legacy application over time. So it's typically more effective, less risky than the going cold turkey, just replacing everything in one go, right? So you do subsystem, you do certain parts, you update it, and you do it bit by bit. However, often we still have both systems in parallel at the same time. Also, when we do migration, we have to make sure that actually the new application has access to the old data, right? So what we have to do is gateways. We have to make sure that we are not breaking anything. So we might have to write wrappers. We might have to do a lot of other things in between. Good, skipping. Also, if we do migration, we have to do testing. And testing is going to be interesting, because how do we test? Regression testing, right? In theory, we should actually perform system or regression testing, right? Except that our old test cases really don't match anymore the structure, right? The implementation of our new system. Because it might be in a different programming language, right? Some parts we might have the source code, some parts we might not. So what we might have to do is we have to test the user interfaces. We might have to test maybe web services. It depends, right? Into what we are migrating. At the end, we definitely have to do system integration testing so that our new application still works with the old ones, right? With the other ecosystem in which it actually lives. And we have to do also performance testing, right? So we have to do functional testing and system level testing. Problem is, a lot of the expertise, people who were actually writing the original test cases, they are no longer around, right? So you might not even know what is the business logic. if you go now in agile development, right? Let's say you have your test-driven development. So you write your test cases, but 10 years down the road, the people who actually wrote the test cases are no longer around, right? So you have no idea what actually you are testing, right? Why you are testing it? Why was it implemented? Why was the test case actually written? What was the requirement which you're actually capturing? And that's what it actually refers to here, right? That's a challenge, even if you have a traditional approach, even with some documentation, because documentation might be out of date, right? So there might be no training material of functional experts, subject matter experts who actually understand. Because remember, the legacy application is capturing business logics. With business logic, you know, how is your business process actually, how is your business actually working, right? What is the flow of information? Who is signing up? What should be updated? And a typical example would be something very simple. Online shopping. A checkout, right? So you go put something in your shopping basket. What should happen with the items in the warehouse? Should it be reduced? Should it be reserved? Should be the stock already removed, or once you put something in your shopping cart? Or should it only be reduced once you do the checkout? Right? So these things are captured in your source code. And if you don't have access to the stakeholders, to the business experts, right? You just read the source code, and you have to try to figure out why and how and what's happening. And it might not even make sense to you, right? Why are they not reserving? Why are they not reducing the stock as soon as somebody is putting it in the shopping cart? But maybe it's the company policy, right? And these things are becoming very, very difficult. And in my example, you are all somewhat domain experts, right? You know what the shopping cart should look like, right? You know maybe a number of items in stock, right, should be reduced. That's still somewhat easy to understand. But some of these business processes are interleaving with other business processes, and life becomes much more difficult. Good. Also, we might have yes. Correct. But so the question was, is it not too dangerous? There is a risk. With any migration, there's a risk. Okay. But you have to pick your battle, right? Are you losing more in keeping your old legacy system? Maybe you can even maintain it, right? Are you losing out on business because you're not providing the functionality? So that's the trade-off, right? So that's why you need the assessment. There's not a single answer, right? So that's why you have to look, how important is the application? And do we have tools, right? So it's a multidimensional, actually, problem, right? And it really depends on the individual context. And then the strategy also has an impact, right? It's all interconnected here. So there is, are we doing chicken little? Are we doing cold turkey? If it's a small application, you can say, oh, I'm doing it cold turkey. Are there components off the shelf that will drive it? So there's a lot of different things, right? But there is a risk, no matter what, right? As soon as you migrate from A to B, things can go always wrong. And typically they go wrong. That's why you keep both applications running, right? Because that's what you would have to do. Trying to figure out what you're actually testing and why you're testing and what are the test cases actually doing. And it doesn't look like a fun job, right? You're trying basically to reverse engineer the business logic. You have to do code analysis, right? Needed. What is the code doing? And you need experts. You cannot have people who are just coming from the university and have no idea. Because they, so if you have available test cases and if you have some, you can try to figure out, right? But it's a really tedious process. Again, at the same time, it depends, however, also how mature the process is in your organization still. If you have consistent traceability and updated documentation, it might be easier. If you have source code, if you have complete traceability where you have links between source code, your test cases and requirements, it will definitely help. So approach to overcome these challenges, start out with smaller parts, right? Try to figure out and testing, and then also identify cross-functional dependencies within the system. So the testing of multiple functionalities can be performed simultaneously. So if you know that A depends on B, right? On system B, certain functions, you have to test, you have to find test cases and making sure that you can actually execute them. So one approach, so you might start with user interfaces. You might compare the layout, right? Are they looking now similar? Now here we are talking about a one-to-one migration, basically, right? Validation of function keys, is everything the same, right? So that would be easy if we have a one-to-one mapping between our legacy and our modernized. Okay. So you run system tests. When you do system and integration tests, module to module, multiple modules, and you want to see if are my application of the GUI still working, and you add more and more functionality. And then you run regression tests. If you have them, if you have recovered tests which have to pass, you can actually run it from your old system. And then what we have is basically here's the whole workflow. You don't have to memorize. It's an example of a workflow which could be used. Okay. But really the goal is, we want to keep our business going, right? At the end that comes. But what one observes is by implementing really migration testing, if it's done properly, you can have your performance improvements of around 5 to 7% overall in the system. Existing defects in the legal systems were identified and fixed, because whenever you do the migration testing, you might actually write new test cases. Right, because you're recovering, you might add new test cases, and what you might identify is that you had some bugs, and they might actually be fixed before, so they might not be transferred to a new system. Because while you're trying to recover the test case, the business logic, the functionality, you might write new test cases, even for the legacy system, because now you understand what has to be tested. And while running these test cases, you might actually find new problems, right? You might actually discover. You might also create new functional documentation as part of the migration testing. because you are redocumenting. Also, you have now test cases, you might have now updated documentation, and you have also skills in terms of employees who did actually the migration testing, right? Who were preparing the migration tests, because we understand now, we have somewhat an understanding what the old system was doing and what the new system is supposed to do. So you're basically retraining, right? Data migration, very interesting. And it sounds actually like a trivial problem, right? So we have one database, bank A, bank B. Both of them have bank accounts, customer information, right? Balances, addresses. Whatever we do with the data migration, it should preserve really the data, right? We don't want to lose by moving from A to B. We don't want to move data, any data. So we move from a relational to an object-oriented database or graph database. We don't want to lose data. At the same time, we also want to take advantage of the new technology, right? Because that's why we are moving. And that's a very important issue, and we will see it. It's not a trivial problem, but if you move from one database system to another one, or from one database to another one, you want to have a benefit. It's not just about moving data, right? Especially if you move into a new technology, you want to take advantage of the new technology. So we have a physical conversion, which is really the schema, and at the conceptual, the data. So the schema is your tables, for example, right? And how they are connected. And the conceptual would be your data itself. Is there any conversions needed? And then we might have also your programs, the application programs, which are going to access the data, might have to use new APIs, right? So you might have to change, you might have to make some changes, maybe to the application, but definitely to the APIs. You have new APIs because you have a new database system, right? A different type. If you're moving from a relational to a relational, it's normally pretty straightforward. But if you're moving from a relational to an object-oriented or graph database system, your API is different for these databases. Okay. Good. Physical migration. So, COBOL, we have a file system, and now we want to move the same thing in a relational data. And that's basically what the schema would look like, right? So the description of a file, and that will be the description of our table. So what are the advantages, disadvantages of a physical conversion? Why do we need it? Why would we actually do it? Why would you move to a new database system, new type of database? Yeah. So more memory, less limitations. Some of the data, unused data. But here we are talking, okay, so we might have files or we might have tables which we don't use, right? Or which might be redundant. Interesting. So, and we might want to remove it, right? A data migration could be also our banks, A and B, right? If we want to combine, we have to get the data from from bank B to the database of bank A, right? So that would be also data migration. Now, what we might have is some of the tables might not exist, right? Because one had brokerage, the other one had mortgages, right? And then we have to still have the relationship. So there's in the schema, we have to update the schema. We agree, right? Oops. Now the interesting aspect is a lot of the data or schema migration could be actually automated. Conversion tools, right? You could have scripts, you can have tools which actually convert a relational to an object-oriented database, or which convert from one version of a relational database to another one, right? For you. But let's go really from a different type of database system, right? Relational to object, relational to graph. So conversion tools, automated tools are cool. They do basically treat the migration as a translation tool. So an automated translation, one-to-one, right? So it has certain rules and then basically replicates that one in the new technology. Problem. What is good about it? Let's start with a positive. And is it good enough? What do you think? So the positive about automated tools. It's easy, right? You just run them and you get a result. It might be syntactically correct. It's like having a conversion tool or translation tool coming from C to Java, right? So it goes quickly, right? And you get something in the new programming language. Similar here, right? You get something in the new database system. Can you see any problems? You don't always get what you're close. You're actually correct. Yeah, you might not always get what you want, but what do you want? No data. Let's say we manage actually, right? The new structure is actually going to be syntactically correct, equivalent, right? For example, like if we are going to migrate some people it's not that everything is there in Azure, right? It has a 99% like some of the exercises which might not be good while you're automating. That is how I think that was a good word. Good, it depends, right? It depends on the abstraction level of our migration. If it's the same technology, it's okay, right? Converting from one-to-one, it's typically okay. But if the technology is different, and I think a good example would be, which is really easy to understand, is we have a conversion tool, let's say from a programming language, from C to Java. Right? Now, these tools work perfectly fine. They can create they can convert your C code to a Java code, which will compile, which will run. But they might not necessarily take full advantage of all the object-oriented capabilities. Why? Because they don't know things like, are you looking for reuse? Are you looking for extensibility, right? We might not, yes, it's going to be a correct Java program, right? But it might be not a perfect. So it's going to be a dirty translation. It's like, Google Translate, right? It's okay, but you are not going to win the Nobel Prize, right? With your translation yet. It's an approximation. It's okay. It follows the syntax or the grammar, right? But it doesn't know really all the semantics. It doesn't know necessarily the style, right? What is actually the purpose? What are you trying to express? Tools cannot yet, right? And number one, let's look at schemas. You have a file system and you want to get it into relational, right? COBOL into relational. Now, creating the tables is easy, but one of the keys in using relational databases are what? Foreign keys, index, right? Which field should be an index? Which one should be a foreign keys, right? Where to optimize the performance later on, right? Now, having a file system only, right? Or just a record, you don't know which is actually the field which should be connecting the tables, right? It will pick something, but it will not know which one should be an index, for example, right? To improve the performance in the query, having some query optimization, right? Becomes very, very difficult for these tools. Now, the tools are getting better. Again, it depends what we are converting to, right? So like foreign keys, right? And now what you have to do is basically trying to figure out what actually should become a foreign key, right? What should we have an index, etc. So you will have to look at the old legacy system. Basically, a user typically has to do it. So there's still a manual optimization. It's similarly, if you convert from C to Java, right? Use it as a first draft, right? But then you would have to clean it up. Oops. No, it goes into. So I made just some examples, right? What you could do, what tools are already doing. They look through the source code. They try to figure out how often is it accessed, right? We might look how much data, and they can suggest, right? They can actually do some indexes of foreign keys. But again, you will have to have somebody to do the final validation. Tools are not perfect because they don't understand the business logic. What is actually the objective, right? They try to figure it out, but they can only do mechanical things. So if you have some comparison between two different tables, right? So there might be, that's a good candidate for a key, right? Foreign key. You can also instrument the code, trying to see how often things are accessed, right? You create traces, you create logs, seeing how many queries are we running, how much data is actually returned. That type of information could be used to optimize later on your new database design. Okay, so here we are talking mainly about the schema and how to optimize it, right? To get a good schema. So the next step, now we have a schema, right? We might want to have third normal form, right? We don't want to have any redundant data, right? So these are all things. So we are happy with our design, but now we want to get the old data into our new design, in our new schema. So now we are actually trying to populate. Again, if we did before just an automated strategy, the tools could probably also do the data conversion for you automatically. Okay, because they know what will translate the structure and they can just move the data. But like I said, it's not typically sufficient, right? We want to really to take advantage of the new technology. You have to have a human customize the schema. Also, the old data might actually violate some of the new schema properties, right? Because certain things might not exist in your new technology, right? Certain types of relationship might no longer be supported. Null values might be supported, might not be supported, right? Simple things. But it could be also the type of relationships. If you have a graph database, what you want to do is maybe, you want to support reasoning, where you allow really complex queries with transitive dependencies, and they require so different types of relationships, right? And also the data has to match. So what we typically have to do is some data cleaning before we actually populate. We should also do some data cleaning, making sure first that the data formats are in the right format, that the data is in the right format. And secondly, if we are already looking for the data and analyzing our data, what we also should do is maybe make sure that we have good data, clean data. Start with a clean, basically use it as a clean start, right? Here are some examples. So we have even two relational databases, right? Two tables with customer information. Source one has customer ID, name, street, city, and the sex of a person. The second one calls it customer number, last name, first name, gender, address, and phone number, right? So that would be our bank A and bank B. And now what we want is, we don't want to lose any of the information, right? So we want to combine it. Now the tricky part is, with combining, the one thing which we don't want to do is create ambiguity, right? Create clones, create duplicates, right? Or semi-duplicates, or inconsistency. So what we have is a new schema, which is given here. And then what we actually, if we would do an automatic, or say through scripts start populating, what we might actually end up with data sets which have similar names and addresses. So we have here twice the same street name, right? The same zip code. One has a client ID. Which one is correct now? Is it Smith Christian or Smith Kristen? Or Kirsten, whatever, right? And then we have the same name, but with a different address. Which one is correct? But it says even a similar number here. Oh, what do we do? So what we would end up if we do it automatically without clicking out, right? If we just merge our data, we might end up getting data which is inconsistent. Suddenly, because you might have moved, but the one bank didn't update the database. The other bank updated your address. Now we have a dilemma, right? And these are the things what we have to find out, right? Inconsistency, possible inconsistency. Could be also, if you're cutting off the names, if you're cutting off the phone number, whatever, right? It might create problems. So what do we do? How do we get rid of these inconsistencies? Any ideas? What would you do? Yeah, but it's not easy, right? How do you figure out, right? So you have two people, twice the same name, but you have different addresses, city, right? Which one is the correct one? You might have actually to call, right? You might have actually to look up. So a lot of this data cleaning might not be, you might not be actually be able to automate completely. You might have to have actually somebody looking through and check it, which is the correct one. If you are lucky, one of the data sources is more reliable. If you know that your data source one is more reliable, it was more frequently updated, it was of higher quality, you can assume that one as your gold standard, right? And if you have twice the same name, same everything, right? Just one change, you take the more trustworthy as your standard. Okay. But then there's also things like splitting up here the address, right? Sometimes it's slightly different spelled, right? Like I know my address, I have 3 different spelling. Once it's re, it has the word re in the front, when it has the French, the chemin. And sometimes I don't use anything, right? I just use lakeshore, whatever, right? Without anything. So if I look at my statements, if I look at if I order something, different websites, I have different addresses, right? It's always me, but with a slightly different address. So that's a typical data evolution, right? It's as difficult as code evolution, right? So you have to have processes. You have to have something in place to keep it clean. It's so easy to get dirty data, right? Noisy data. Because that's the last thing what you want, right? Is noise, inconsistent data. So what you should do is define inconsistencies and detect them, verify correctness and effectiveness, sample, copy of the data, whatever, right? But it might be a copy of the data. You might have to do further analysis. You might just keep also the old data, right? Before you discard it. Maybe you still need it for some applications. Also another issue, right? So, good. But once we know, once the data is cleaned up, we can have data transformations. Just to populate data, right? Which is a common thing. But before you really populate, you should clean up your data. So have been detected, you remove them, you modify data so that it matches. If the new fields are 32 characters, you have only 25 in your old one. You have to make sure if you want to have the spaces in the front, in the back, right? Small things, but they have to be done. Now we have the data, we have a schema, we have our schema, our database populated. And now the next thing is we have to look at our application programs which are accessing the database or the data. Now, the applications, we might be able to change, but we don't want to change them typically because whenever we change something, we have to do regression testing, right? So what we typically try to do is the new database basically has an API, right? We have a new data format, we have the fields, and what we should do is writing wrappers which do the conversion for our old legacy application. For example, in the old application, one data came from one table and the other one came from another table. Now we merge them in one table. So we might have to split it up just when they are again in two fields, right? For the legacy application, for our old, for our systems, or vice versa. Okay. Example would be the old one. If we go back, the city. So we have applications which basically took the city as name, zip code, right, as a string. But now in the database, in our new database, we are split up, right? But we don't want to change our old application programs. So we only said, give me the street, or give me the city name, or give me the city or the address, right? Now what we do is we create another API between, which doesn't add any functionality, but which only does the conversion, so that we don't have to change our application programs. So the database is up to date, and the wrappers do the conversion needed. Similarly, what we would do, like traveling, we have a power adapter for your outlets, right? 2 branches to Europe, right? You need a different one as in North America. Good. So that's what we have. So we have our legacy code. Yes. Good. I'm almost done anyways. I have a few more slides before we go into cloud-based migration. So basically what we put is a middle layer, right? So the legacy code calls the wrapper, and the wrapper does the conversion and accesses the new data. Okay. Yeah. So these wrappers preserve the logic of the legacy application. So there's no changes in functionality of the legacy application. And we could have a conceptual wrapper where we actually might have to do some additional conversion and updating, but different issue. Short break, and then we continue with cloud migration. And let me see. So if you see COM354, it's just I use the same template. Right. Sometimes my undergraduates get the slide template from this course, but so let's look at another type of migration. This time we are moving to a cloud. So which is what a lot of organizations are doing these days. And then as part, I prepared today another set of lectures, notes, brand new, which I will talk about next week for maybe half an hour. They are about different case studies, trying to see.
Next week or
Yep. Yep. Very good. So I have next week half an hour, maybe lecture notes. And it's going to be about automotive industry and DevOps and other things, right? Development for cars and software evolution. Okay. And then I will talk about assignment number 3. We will go over the solution. I will talk about assignment 4, and I will go for each of the questions. I will also post by next week the coverage. And I will have another assignment for, I call it assignment, but it's for you to get ready. And it will be maybe one more slicing problem, right? If need be, and some other types of questions. I haven't written the exam yet, right? So it's going to be a different exam, but I will give you maybe old exam questions to get and I'll give you an idea. Okay, good. Plus, I might set up a Zoom session after we are done with teaching, closer to the final, right? Which is on which day? I hear 26. Somebody was saying I'm not allowed to say it, right? Okay. I might set up, 1 or 2 Zoom sessions, drop-in sessions where you can ask questions. Okay, but I will post it on Moodle. Good. Paper report, the marks will be posted. Assignment for the marks are straight. I need just a couple of minutes for that one. It's easy. If you submit it, you get, and you have written something decent, you get 100%, right? But I will look for the assignment 4. I will look actually through them, through your submissions, to see if there's a problem with something, right? I use them as a feedback, but I can actually see if there's a problem. So that's my hope. Everybody did it by themselves, because that way I can actually see what you know, right? That was the whole goal. I'm not looking for perfect solution, because otherwise I assume everybody knows everything, right? If one person does it and 5 people are copying, I assume everybody knows everything, right? So as long as you put some effort in, you get anyways 100%, right? If it's right or wrong, I don't care, right? Cloud. Everybody likes the cloud, right? Everybody wants to be in the cloud. What is the cloud? No, today wasn't cloudy, right? No clouds in the sky. What is the cloud? Talk to me. Any ideas? Why is it called the cloud? Why would we move? You get.
It's not feasible to have the data small and hardware. So we have to use a cloud represents any amount of data we can use.
Any amount of data. How did we do typically? How did we do? What was our infrastructure in the past? How did we deal with our application and data?
And we need to have hardware and the car.
So we had the hardware. And who had the hardware? Our organization, right? You as a company were hosting your own hardware. On that hardware, you were hosting your own software, your own you were taking care of installing, maintaining the operating system, the applications. If you needed more hardware, you had to buy it, right? If you had to replace it, you had to take care of it. So, and really the cloud computing says, hey, plus, if I go really, and the other part is, now you had a business which was very, had peaks. Let's say the peak was Black Friday. On Black Friday, you get suddenly 5 million transactions a day, right? The rest of the year, you only have 10,000 transactions a day. How many resources would you have to buy traditionally to keep your business going? You had to buy hardware, CPUs, which can support 5 million transactions, right? Even if you only used them 1 day a year, but you didn't want to lose out on these 5 million transactions, right? The rest of the year, the hardware was basically idling. So you had all these CPUs, all that memory, right? All that hardware invested, but 90% of the time it's not used. So and that's one of the things why companies move to the cloud. Another issue, right? You get basically, you only pay what you use. Okay. So, and we will look a little bit at it, right? So if we look at an IT infrastructure, that's actually what it looks like, right? We have dealing with data, applications, storage, network, servers, middleware, operating systems. Okay. So we have different parts. So why would companies decide to move to the cloud? Reduce the IT infrastructure cost, lack of appropriate IT resources for changing markets or industrial demands, faster, more reliable data processing, improved data sharing and remote access capabilities, all of the above. Yeah, and your answer is all of the above. And you are correct. Okay, good. And that's basically, your current hardware, your current infrastructure didn't really support your business anymore, right? You want to be able to expand, but you don't have really the resources to have something just standing around maybe most of the time. You want something which is more efficient, which scales. If your business peaks, you want to be able to have a quick adjustment without having to go out and buy and install and upgrade. Also, you might want to get rid of your old legacy applications. And remember, so here we are talking about again legacy migration, because your old legacy application might not be available with a web interface, whatever, right? It might not scale. It might have a lot of different problems. So you don't want to invest in a refreshment of hardware or whatever, right? You want a quicker return of your investment. Not first investing a large amount of money and then hoping you recoup it later on. So cloud, you see it, right? Advantages, its speed, long-term cost efficiency, etc. Now, if we talk about cloud service models, there are actually different service models in the cloud. And each of these has certain properties, certain levels of outsourcing. Let's say, call it outsourcing of our IT infrastructure, okay? We do have a software as a service, which provides the customer with commercial off-the-shelf software, and it's typically within an established cloud platform provider. We have a platform as a service, provides the customer with the capabilities to develop now. So we not only have components off the shelf, so you're not running a standard application. Here you can actually customize your application. You can develop your own within an existing cloud provider. So you host your application, your customized application somewhere else, right? And then we have an infrastructure as a service, provides the customer with a customized cloud infrastructure, complete with processing, storage, network, and other equipment. So everything. Okay. And you have basically control over the development and deployment of that infrastructure. So infrastructure as a service, it includes everything. The hardware, the software, and you have full control over it. So if we look at it, software as a service could be your Google Apps, right? Your standard Google Apps. And software as a service, everything is now hosted in the cloud, the application, everything, okay? For the platform as a service, the application and data are still things you are managing now. And here, the red one is what others manage, what the cloud provider is managing. So here, as a software as a service, everything is managed by Google, right? Here, platform as a service, the application and data are managed by you, but runtime and by middleware operating system are managed by the cloud provider. And then we have the infrastructure as a service, application, data, runtime, middleware, operating system are actually managed by you. So you have control here, and the rest is managed by the cloud provider, the virtualization and resource allocation, etc. Because we are going to optimize the own backend, right? We make sure that the backups are there, etc. And then on-premise, traditionally, that's what we had, and you would maintain everything. You have control, but you also manage everything, right? And here are some of the examples. So we might have also platform as a service, could be AWS, could be Azure, Windows Azure, right? Which basically provide the infrastructure here, provide the services. And then we have the infrastructure, could be AWS, Amazon Web Services, etc. Also, we can have different deployment models for the cloud. So we have the service models, and then we have the deployment model. And it's really about the visibility of the deployment. And what we have here is basically we could have a private cloud, you could have a public cloud, or a hybrid version of the cloud. A private cloud, a company provided via a private internet network. So most often for an intranet, right? So you limit basically the visibility of your cloud infrastructure to your organizations typically, or to a limited, right? Could be a government, could be the military, right? You don't have access to the military. Even if they use cloud computing, right? They limit, right, the accessibility. So security, data, etc. Okay. So you limit the accessibility. However, if you have a private cloud, you might limit again the scalability, because within your organization, even if the military, right, has their own cloud infrastructure, the private cloud, yes, they can share the resources among the different branches of the military, among the different parts of the military, but still, they might run into a limit because they have to still take care of the resources, okay? And then you have a public cloud. So which are the ones which we, for example, the public internet, AWS, Amazon, Azure, right? Now, they often host components off the shelf, right? Because they want to make sure that a lot of companies use the services, right? They provide certain services, microservices, larger services, standard services, to have a larger customer base, right? You can access. So the problem with the public cloud, include limit of customized cloud solutions often, because they might not allow everything, right? And they might not be able to secure the data and privacy, because it's hosted somewhere on the, you might not have even any idea which country that data servers are stored, right? In some circumstances, or where the data centers are located, right? And so you have limited control often about the data governance, where your data is hosted, right? Which is becoming a bigger issue these days, right? Because certain data is somewhat security sensitive, right? And for example, do you know where your OneDrive, your Google Drive data is actually hosted? In which data center? No idea, right? Now, what it also means is obviously, right, since you have no control which data center, you don't know which government is using it, right? Which organization might be using it. So that's the tricky part. Now, but at the same time, these data centers can be obviously further optimized, right? Scalability, because we have a larger number of customers and they can offload some of the peaks, right? Work around, and we do have different even incentive organization, right? So these cloud providers benutze incentives to balance the workload by saying, you know, if you go off peak, it's going to be cheaper to use the CPU or the data as during the peak hours. And then you could have a combination of both, which is what more and more organizations these days are actually aiming for. They have some of the, privacy or security related, data where we have to make sure that there are no breaches or whatever. We will host them in the private cloud, and then some of the applications, which might be just on the public cloud. How much goes in the public and private cloud? It really depends, right? Depends on your company organization. So private cloud could be Zoom for government, right? And also you don't want your Zoom being hosted on the public server, right? That everybody can maybe listen in, or you want to know. So what you do is you run it on the private cloud. You have your own installation of Zoom and you provide it only within your own organization. And then a public cloud could be Microsoft Office, right? Which is globally, you don't know where it's hosted, you have really very little influence. Okay, good. So migrating to the cloud is a big business. So in 272 billion in 2018, and it's growing to 623 billion by the year 2023. So the cloud market is growing in the migration. But whenever we do move to the cloud, again, we have to do, it's not just saying, I'm going to switch everything, right? You have to determine, we have to do again the assessment, we have to do the migration assessment, we have to look at the cost, we have to look at the benefits and how difficult it is to migrate. And typical cloud migration process is for infrastructure development, then we have a platform development, and then we move at one point our application and data. So it's a multi-step process. So it could be from a transfer of the data points across several applications to a large-scale migration effort across multiple data centers. So it really depends, right? Maybe we want just to move one database, maybe we want to move all the data and all the application. Again, there's not one single, right? It really depends on what you want to migrate. So one would be rehost, lift and shift, so migrate legacy data to ready-made cloud platform. And what you basically do is you just optimize, right? Similar what we did before with data migration. You look again, optimizing of a cloud environment. You might have different types of tables or indexes. You have a larger amount of memory. You can put the index on something else. Things you couldn't do maybe before, right? When we have a re-platform, develop a cloud platform, and then optimize the legacy application for cloud native to a cloud native platform. So here now we actually think about the cloud environment operating system, and we actually want, and we are going to migrate it as a platform. Or we could just repurchase, drop and shop, discontinue legacy application in favor of a new cloud native application. So that would be what almost like our cold turkey or replacing, right? No, it's not cold turkey, because we would have actually something which is equal, right? We could refactor, redesign our legacy application architecture by developing cloud native features for deployment to the cloud. So we could say, certain things might run on the cloud, certain parts. A subsystem might run on the cloud. But then we would have what to redesign, restructure our old legacy application. You could say, we host now our data. Our database is going to be hosted in the cloud. But there will be some redesign, restructuring necessary of your legacy application to connect now to the cloud infrastructure, right, etc. Retain and retire. Even if we move to the cloud, or if we give up on our application, we definitely should retain, have a backup of the old data, of the old application, just in case we need it at one point. And retire, prepare legacy data application for disposition, get rid of it. So here we create a backup, right? We keep everything, and then we would discard it. And that would be basically, so we could rehost, we could re-platform, we could repurchase, we could refactor. These are our alternatives, right? From our legacy application. And then we do a transition to the cloud. Important, think first, plan first, rather than just jumping the wagon. Meaning, plan, think, what are you trying to get out of it, right? Where do you have your biggest bang for your buck, the biggest return, before you actually do the migration to the cloud? Not everything has to be in the cloud. Okay. So, ideal situation, you need new hardware for something, right? You need a new database server. That might be a good point to actually think about the cloud migration, right? rather than buying at that point, but if your database server is still okay for the next 1 or 2 years, right? It has enough storage, it has enough, your database server has enough memory, right? There's no performance problem. You might want to delay it, right? You might not have to rush. Look at an opportunity where it actually makes sense. And what you see is basically we have different types of strategies, models. And so first you would look at the requirements, what is the goal, and then you look for the appropriate solution. So here you get your business planning, you have your migration, thinking about preparation. Then you look at the different cloud providers, what's actually out there, you select the right one. Then you start with the application design or with a migration and validation. But important here, right? You have multiple cloud providers. Some of them are cheaper, some of them are more reliable. And these things have to be considered before you actually move. And then we have operations at one point. So which of the following represents the largest cost driver when migrating to the cloud environment? Getting rid of the old IT infrastructure, size dimension of the transferred data, storage cost, data integration validation cost, or post-migration maintenance cost. So there's no all of the above, right? So it's actually one of them. And it's really the size dimension of the transferred data. So what we have to look at is, because the data can be huge. If you have big data, right, you have to transfer the data. You have also to make sure later on, hosting the data is not free. Updating the data is not free. Having transaction on the data querying, it's not free, right? So there's a cost involved. So the question is, should be rehost, replatform, refactor, different levels of moving the data, applications, things to consider. Just looking. Cost drivers for an organization consider size dimension of the data housed in the legacy system, right? How much data we have to move, amount of the data to migrate onto cloud environment. So we look first how much data we have in our organization, how much are we actually going to move. And then we have to look at the data integration migration costs. And important, cybersecurity. Now you assume that your cloud provider has the security, but if you have a private cloud, you're in charge, right? Also, is cybersecurity sufficient? What your cloud provider is providing? Do you have to encrypt, decrypt the data before you upload it? On top of it, size metrics, may cost associated with infrastructure audits. So you might have to audit, you might have to verify if you meet all the requirements, if the cloud provider is still secure enough. So there's a lot of things to consider. Cybersecurity, because now you're hosting it outside. And you have to make sure you're not getting in trouble, right? In terms of vulnerabilities, in terms of data breaches. And we hear it often, right? Somebody got the addresses, right? Somebody got, yeah, why? It's not necessarily the cloud provider per se, right? It might be the cloud provider, but it might be also the applications. It might be the way how you encrypt or decrypt the data. Maybe the data transfer was not secure enough. So, and you see, especially governments, banks will have that issue, right? They have to have compliances. They have to follow regulations and what is and how things are hosted. So they might have certain security models which have to be followed. But there's zero trust security models, meaning you cannot trust the cloud provider. So what you need is encryption. You need encryption keys. You might have your access management, etc. Right? So what you do is basically preliminary cost estimation steps. You look how much are you spending, where do you have currently the most spending in terms of hardware, infrastructure, maintenance, operations, and then you use that one to determine where you have the biggest bang for your buck. Okay. At the end, it comes down all you want to save money. In the long term, you want to save money and you want to be able to meet all the business requirements. Now, cloud migration is not going to be free. There will be a cost associated upfront. Any type of planning, any type of evaluation will cost you. But there should be a long-term benefit in terms of you basically outsource operations, right? A lot of operations which you had, like if you use the cloud for everything, your operating system, your virtualization, everything is there. You don't worry about hardware, upgrading hardware. You don't worry about upgrading the operating system. They provide a stable environment for you. You don't worry about backup, data recovery, which is all part of operations typically, which you can actually outsource. Plus, like we mentioned before, about resources, optimum use of resources. Cost with cloud computing, however, is also like you need network connection, right? And I think that's what I have in the next one. So you need to utilize cloud services to maintain relevancy. Not necessarily, right? Your business, your organization can work just fine. Not everybody needs the cloud. Okay. You have to make your business point here, right? You have to see that you actually get a return for your money, return for your investment. So just because you're not in the cloud doesn't mean that you're behind, right? You're behind other companies. Your application might be just perfect. If you can host it internally, if you can manage it, if you're given resources, you're okay. Cloud should be everything, should be used for everything IT. Cloud is useful for managing unpredictable workloads or when network scalability is needed, right? But not all applications faced with resource peaks, right? A lot of applications might just run the same workload all year long, right? And you get basic perfect utilization of your hardware. Again, very difficult to make a point to move it to the cloud, because with the cloud you have network connection, which you have to network transfer, data transfer, which you have to pay for. So there is also cost involved, right? Like for any other service. No service is free. Multi-cloud strategies will prevent vendor lock-in. So some companies, some organizations try not to become dependent from one single cloud provider. They use multiple different cloud providers. They say, okay, we migrate that application in that to that cloud provider, the other one to the other one. So it can help, right? It can create some independence. However, you might have problems at one point to connect with different clouds. It's an extra overhead again, right? Because the APIs are slightly different. And now suddenly the communication overhead, trade-offs, right? Like with many other domains, if you have one single provider, it's easy, it's all centralized, right? You have only to deal with one cloud provider, but you're dependent. If they raise the prices, you have no choice, right? Once I move to the cloud, I'm done. No. You still have to update. You still have to maintain your application, right? You have still to add new features. You have to still to add new functionalities. Cybersecurity. And again, it depends how much we move, right? And at what level. Might still have to reflect our application. Even your cloud service provider might change the APIs, the interfaces. And if your data interfaces are changing, your legacy applications still have to be modified. So cloud migration, no silver bullet, but you have to, you basically have to prepare it. You have to plan it. Don't do it ad hoc and say, just we do it. Should use cloud strategy or vendor. One cloud strategy or vendor. So that's the thing, right? One cloud provider might provide not everything. Might not provide the necessary scalability. Peak pricing might be different. Again, so there are the pros and cons, right? Good. I might actually start with the next slide, which I prepared today. We have fun. And then next week, we just do a review and, okay. We'll go for 10 more minutes and then finish the next week, okay? Automotive software, and we are talking here mostly about software, okay? And you will see probably interesting things. So I'm not focusing on the car manufacturing, which is a completely different game, right? On software used for manufacturing of the cars. I'm talking mostly about software used in cars these days. And we will talk a little bit about IoT and predictive maintenance. My cars, my automotives, they are becoming some of the biggest ecosystems, software systems these days. Some cars have more than 300 million lines of source code. Where is the source code? How come that we have so much source code? Any ideas? Talk to me. How can we get 300 million lines of source code? Where's all the source code? Is it your user interface? Where's all the software? Why is it so much software? Any ideas?
This is one of the part of cloud which we have discussed. We have to create.
But why? How do we have 300 million lines of source code in the car?
Not in the car. I really this is specific.
Some cars today would boast more than 300 lines, 300,000 lines, 300 million lines of code.
If the entire car will be operating, but at a specific time, we get written data.
Just in the car. Interesting. You know where the code is? Every sensor has some source code. Every sensor has maybe its own operating system, right? How many sensors do we have in a car these days? Hundreds of sensors. Each sensor has its own implementation, runs on some operating system, right? It has to run on something, right? Agreed? And suddenly we have rather complex systems. Good. And yes, we can have vehicle-to-vehicle communication now, vehicle to the cloud, and I will talk a little bit about this extension. But even on the source, really just on the car itself, these become very, very complex systems. Self-driving, right? Oops. Evolution. And that's also part, so we are looking at the evolution of the self-driving features, right? But that evolution comes with software, really with sensors, and each sensor uses software. Because sensor mechanical is not good enough, right? It has to be transferred somewhere and interpreted information. So we are now what? Level 3, give or take, right? Borderline, so that you can take the hands off, it actually give different directions, and the car should be able to drive you to the destination by itself. But the driver has still to be in the driver's seat and be ready to take over. In Canada, we have probably, that works level 3, works maybe in California. I wouldn't trust level 3 here in Canada. With our road conditions, with wind or with snow, right? In best case, we are somewhere below. Even cars which are on level 3 in California, where it's sunny, you know, you have road markers, you have no potholes, you have no black ice, you have no snow, right? Very different environment here. And level 5, fully automated. You can see the back seat and have a party. But to get there, what do we need? We need a lot of software, right? A lot of sensors, a lot of data, and a lot of analysis. Another way of looking at cars and maintenance is preventative maintenance. And or even here, so we do have different types of maintenance. We talk about software, right? What is our different types of maintenance? What we have? We have perfective, corrective, right? Preventative, adaptive, right? So how do we normally maintain our software? We do mostly perfective, right? No, it's corrective or perfective, right? It depends how we look at it, right? bug fixes are probably the largest number, right? In terms of quantity. But from a cost perspective, effective, right? Adding features and functions. Now, in the auto industry, for cars, we have actually reactive maintenance. They call it reactive maintenance, which would be in our case, corrective maintenance, right? We have a bug which we have to fix. So our system fails, we break it. We fix it. It's broken, we fix it. For cars, we also have preventative maintenance. Every 10,000, 15,000 kilometers, you have to go to a garage to get a schedule of maintenance. And the idea is you want to delay the failure, right? By replacing things, reducing the number of failures, right? You just replace things on a regular schedule. Where's the schedule coming from? Based on experience, right? Based on your business model, whatsoever. But really the idea is you want to reduce the number of failures. And then there's something which is called predictive maintenance, which is starting to take more and more place now in cars, in the automotive industry and in cars. Where you have basically software determining based on the usage, right? How you use the car, how many kilometers you drive, environmental factors. And it would determine something that doesn't look right anymore. And before it actually breaks, it would send you to the garage, fix it. Okay, good. Now, actually, that's what we see also coming in software. Preventative maintenance or predictive maintenance is actually part of almost of also DevOps, right? Because we collect now some information, we have some runtime information, and before it actually breaks in DevOps, you might tell the developers, right? Hey, something might need to be updated, upgraded, because operations determines the system is running slow, response time is going down, right? And you can actually, before it actually comes to full stop, before actually the customer would notice, we start now providing developers with feedback from operations that it looks like we are going to have a problem. So that would be number one. You could have your mining software repositories. You're monitoring your system. Other places where we have more and more bugs coming in, right? And you predict now based on the statistical data and machine learning, you can predict, right, potential problems and try maybe what to resolve before they actually happen. Oops. So run to failure or reactive maintenance, that's our corrective maintenance, right? Then we have planned preventative maintenance, refactoring, right? Cleaning up the code, removing technical debt, right? Because we know it might break, so we better clean it up before and trying to delay it. Or here for cars, it would be scheduled. And then we have predictive maintenance. So here we would actually monitor. We have constant monitoring of the system, big data analysis. Okay. One more slide, and then we call it a day. So, and then basically predictive maintenance could be, we monitor trouble codes, so we actually collect data from sensors, right? Which can help us finding the bugs before they actually happen. Similar what we actually do also with modern software. You do often have traces, you often have log files, right, which are monitoring. You have dashboards to see activity, cloud computing, all these different servers, all these different storage devices, right? They are monitored and they know before something fails. switch over, right? Tracking vehicle health indicators. Most cars, many cars have no more fixed oil change intervals. Right? They have variable ones. They predict the oil change based on the actual usage, the climate. So rather than having your schedule every 10,000, you say, depending on the usage, if somebody is driving in the city, it's cold, only drives in the city, might be 5,000 kilometers. If somebody drives in California only on the highway, same speed, it might be only 20,000 because the oil lasts longer. Also, similar what we had with DevOps, anything which we monitor, and here could be a car, that information goes back to development, which is your original equipment manufacturer. That part is using too fast, right? So that type of information is really very, very similar. So our original equipment manufacturer would be our developers, right? And operations is actually anything what we collect from the car. Monitoring from our sensors. Good. Let me continue. I have maybe 10, 15 minutes next week. I will talk about assignment 3. I will talk about assignment 4. I will post the solution for assignment 4 by the weekend latest. 4 and 5, yes. How many assignments? 4 and 5 here. Yeah, I'm getting confused. And I will also post the coverage. And then we will do a review before the final next week. Okay? Good. Sounds like a plan. Thank you. Have a nice evening.